Let's just dive right into this explainer because today we are unraveling one of the absolute most fascinating scientific mysteries in West African history. We're looking at a story that brings together ancient metallurgy, some fiercely heated academic debates, advanced atomic mathematics, and a truly massive global trade network. Picture this for a second. You're literally just digging a simple water cistern in your backyard, right? And boom, you stumble on evidence that completely shatters accepted historical timelines. I mean, no way, right? But that is exactly what happened here. It turned a quiet little piece of land into ground zero for a massive archaeological reevaluation of sub-Saharan Africa. 165,000. That is the staggering number of glass and stone beads recovered from this one single site. When you hear a number like that, you know right away it hints at a massive ancient global network. We're just talking about a couple of isolated artifacts here. We're talking about what must have been a major hub of commerce and high art.
So here's how we're going to break this down today. First, the accidental discovery. Second, the chronology riddle. Third, the science of time. Fourth, the trans-Saharan trade connections. And finally, preserving these ancient masterpieces.
Okay, part one. The accidental discovery, unearthing a lost civilization. Let's start with the crazy luck of how these things were actually found, because history so often hinges on just the most ordinary moments. The year was 1938, where in a village called Igbo-Ukwu in Anambra State, Nigeria, a guy named Isaiah Anozie was doing an everyday chore, literally just digging a water reservoir, or omi, in his compound when his shovel hit something metallic. What he accidentally dug up turned out to be some of the earliest, most elaborate examples of copper alloy art in all of sub-Saharan Africa. Decades later, in 1959, scientific excavations by Thurston Shaw revealed over 1,300 bronze, copper, and iron objects, along with tens of thousands of pottery fragments. And honestly, it brilliantly shows off the insanely advanced metallurgical skills these ancient artisans had. They were using a really complex method called cire perdue, which is the lost wax casting technique. It allows for immense technical complexity. They were making these intricate hollow bronze sculptures with incredibly detailed naturalistic decorations. I mean, they were casting things down to the tiny legs of insects. The artisans of Igbo-Ukwu were very likely among the very first groups in West Africa to master this whole process. Which brings us to part two. The chronology riddle, the academic clash.
Now, you'd think finding masterpieces like this would be a purely happy moment, but it actually sparked a really heated academic debate that dragged on for decades. Scholars simply couldn't agree on when these things were actually made. On one side, you had Thurston Shaw, the archaeologist who led the digs, pointing to early radiocarbon tests that said these bronzes dated all the way back to the 9th century. But on the other side, scholars like Babatunde Lawal argued heavily for a much later 15th century date. Lawal and his camp just felt an earlier date didn't fit with what was assumed about the region's technological timelines at the time.
And to be fair, the skeptics brought up some highly logical concerns. For one, they argued that across the three excavation sites, Igbo Isaiah, Igbo Richard, and Igbo Jonah, the carbon samples were pulled kinda disproportionately from just one or two spots. But the big thing was the physical environment. We're talking about a damp, equatorial rainforest climate with a ton of termite activity where organic stuff decays super fast. They really questioned how on earth organic artifacts, like wood or textiles, could possibly survive from the 9th century without rotting away completely. So they just assumed the radiocarbon samples had to be contaminated.
Let's move to part three, the science of time, solving the mystery.
To actually settle this impartially, we've got to drop the assumptions and look right at the hard data. And what's really cool here is how scientists use the steady, predictable decay of carbon like a giant natural clock. See, every living thing absorbs two types of carbon, stable carbon-12 and unstable carbon-14. When an organism dies, it stops absorbing carbon, and that carbon-14 starts dropping an electron, decaying at a totally unbroken pace. That's a half-life. Today, we know for a fact it takes exactly 5,730 years for a sample to lose exactly half of its carbon-14. So by measuring the carbon-14 that's left in organic stuff from the site, like, say, wood from an old stool or charcoal from a fire pit, and running it through a specific mathematical decay formula, researchers can estimate its age. By comparing that remaining carbon-14 against the stable carbon-12, the math literally lets us calculate backwards in time to the exact moment that organic material died. It's wild. But because of those very real worries about climate contamination and historical changes in atmospheric carbon, modern scientists didn't just stop at base radiocarbon testing. They ran a super rigorous three-step process. After the base C14 tests, they brought in dendrochronology, which is analyzing ancient tree rings to adjust for historic climate variations. And then step 3, they used uranium-thorium recalibration. This is an incredible technique that uses mass spectrometers and magnets to sort atoms based on mass and electrical charges. Basically, it acts as a rock-solid secondary check against the carbon data. And the results? Well, this consolidated data is our final verdict. When you take the original radiocarbon dates, average in the tree ring corrections, and apply the uranium-thorium recalibrations, 4 out of the 5 primary samples mathematically cluster super tightly around the late 9th and early 10th centuries. So science definitively backed up Thurston Shaw's original timeline. The skeptics were just wrong. The Igbo-Ukwu bronzes really are that ancient.
All right, part 4, Trans-Saharan Trade Connections, a global hub.
Now that modern science has completely locked in that 9th century date, we start to realize just how historically massive Igbo-Ukwu really was for the broader African narrative. This definitive timeline proves that Igbo-Ukwu's advanced metallurgy actually predates the super famous art centers of both Ife and Benin by centuries. Ife's amazing bronzes and terracotta really took off around the 13th century, and the famous Benin bronzes around the 16th century. But Igbo-Ukwu, they were already knocking out highly sophisticated, technically complex copper alloy masterpieces way back in the 800s and 900s. Plus, the artifacts tell this incredible story of global connectivity. Remember those 165,000 beads? The sheer volume of those beads, mixed with buried elephant tusks, confirms these people were deeply plugged into early trans-Saharan trade networks. Research shows striking similarities between the beads at Igbo-Ukwu and beads found way over in the ancient city of Gao in Mali. It's super likely Gao was acting as a middleman, moving goods right down the river Niger, connecting these Igbo-Ukwu artisans all the way to markets in Egypt and beyond. They were literally trading local ivory for foreign glass and copper. It was a whole global economy.
Finally, let's wrap up with part 5, Preserving Ancient Masterpieces, the Modern Effort.
So, why does all this matter today, and what are we doing to protect it? Well, 350. That's the number of culturally significant Igbo-Ukwu bronze objects sitting in the National Museum Lagos collection right now that desperately need full conservation and structural analysis. Over 1,000 years after they were poured and cast, a lot of these fragile objects are corroding. They need help. Thankfully, supported by a major 2022 Global Arts Grant from Bank of America, the National Museum in Lagos is taking critical steps to treat these aging masterpieces. This grant, which was actually the first ever specifically for the conservation of the Igbo-Ukwu bronzes, funds an 8-month on-site process. It brings in expert conservators to consolidate and restore these objects so they simply don't deteriorate any further. There's a quote from Brian Siegel that I think just hits the nail on the head regarding our shared responsibility here. We absolutely must actively preserve these earliest known regional examples of bronze casting for future generations. It's about letting museums show these objects in their absolute best state for public education and forever cementing their rightful place in global art history. It really leaves you wondering, doesn't it? I mean, if a guy just doing chores, digging a simple water cistern, could accidentally uncover a 9th century civilization with literal global trade ties. Just how much of human history is still buried right beneath our feet, waiting for the right scientific tools to finally tell its story?